All right, for these examples, we are going to find the x and y intercepts if possible. All right, now we say if possible because technically, I'm just going to sketch this out really quick. Sometimes we'll have functions, and especially if we have like a quadratic, it can look something like this, right? So if it's a floater, it doesn't cross the x-axis, then we say that there's no x-intercept. So that would be an instance where the x-intercept is not possible. All right, so that's just a really quick explanation for why it's included right here. Okay, but for these examples, let's take a look. And I'm going to do that. Okay, so the first problem is y equals 2x squared plus 7x plus 3. All right, so I'm first going to go ahead and find the y-intercept. Because technically, y-intercepts tend to be a little bit easier because all we have to do is use this idea, this fact that they occur when x is equal to 0. So that means whenever we find a y-intercept, all we got to do is plug in 0 for x. Okay? So what does this one look like? Well, I'm first going to rewrite the problem. So we get y equals 2x squared plus 7x plus 3. And now I'm going to go ahead and plug in 0 everywhere I see x. Okay, so it's almost like if I were to replace x with a set of parentheses. So I get 2 times whatever plus 7 times whatever plus 3. And then those zeros are going to go right inside of those parentheses. Okay, because I just replaced x with 0. That's it. Okay, so when we solve this one, we get y equals, well, this turns into 0 plus 3, meaning y equals 3. So what does this mean? Well, this tells us that our y-intercept occurs where y is equal to 3, and it has the coordinates of 0, 3. Haha. All right, so that's our y-intercept. Knocked it out pretty nicely. But now let's take a look at our x-intercepts. All right. Now, x-intercepts are a little bit different. Actually, they're very different. Not even a little bit. So this is what we do for our x-intercepts. So I'm going to put s in parentheses. All right. So similar to what we did with y-intercepts, what happened with x-intercepts? They occur where y is equal to 0. So let's go ahead and use that fact to help us find our x-intercepts, or our roots, or our solutions, or our zeros. Okay? All right. So again, these happen when y equals 0. So I'm going to copy the problem again. We get y equals 2x squared plus 7x plus 3. Okay. Now this time I'm going to plug in 0 for y. So we get 0 equals 2x squared plus 7x plus 3. There's something special here. If you notice this part, we have done this before. We've done a bit of practice with it way back in September. if you refer to the module or the lesson solving by factoring and ZPP, zero product property, this is the same exact thing that we're going to do in order to solve for x. Okay, so if you are not really familiar with factoring, I need you guys to review these videos again just to refresh your memory. Okay, so I'm most likely gonna include a link to those videos in a bit. Okay, but this is basically how we would factor to solve this quadratic. All right, so all I'm gonna do is, well, I can rewrite 0 equals, and when we factor, again, we break it up into two sets of parentheses. Okay, two factors. Okay, the first two factors, the first terms, they need to multiply to 2x squared, so that'll be 2x and x. And then the last two terms, they need to multiply to 3, so I'm thinking 1 and 3, positive 1, and positive 3. All right, so how do I know I factored correctly? All we have to do is check our work really quick. So I can multiply the two outside terms together, which is 6x, and add it to the two inside terms multiplied together, plus x, and 6x plus x gives us 7x. So meaning this, since this 7x matches the middle term that we have here, that tells me I factored correctly. Yay! All right. So we factored correctly. Awesome. All we got to do now is use the zero product property to solve for each x. Meaning we're going to take each factor, set it equal to 0. So I get 2x plus 1 equals 0. And I get x plus 3 equals 0. And I'm going to solve for x. All right, so on the left, when I solve for x, I'm going to subtract 1 first. So this gives me 2x equals negative 1. And now divide by 2 on each side. That gives me x equals negative 1/2. Awesome. So that gives me one solution, one x-intercept. All right. On the right side, to solve for x, all I have to do is subtract 3 from both sides. Bam. We get x equals negative 3 here. And now this gives us the second x-intercept. All right, so again, what does this all mean? This means that our x-intercepts are going to occur where x is negative 1/2 and where x is negative 3. This will give us the coordinates of our x-intercepts of negative 1/2, 0, and negative 3, 0. So there are a couple of different ways to express our x-intercepts. You can either identify the values themselves. We can say it occurs when x is negative 1/2 and negative 3, or we can we can write out the points negative 1/2, 0, and negative 3, 0. All right, so that is number 1. This is how we find the y and x intercepts of a quadratic. Okay, let's take a look at number 2. Haha, okay, so this one is fun. We are going to do the same thing. So let's look at the y-intercept first. Again, this occurs when x equals 0. So let's go ahead and rewrite our problem. So I'm going to get f of x is equal to x squared plus 4x plus 3. I just rewrote it. Now we can plug in 0 for x. So we say we're going to evaluate the function when x is equal to 0, or f of 0 equals, and again, we can replace each x with a set of parentheses here. And wherever I see parentheses, I can plug in my zeros. So we get 0 squared plus 4 times 0 plus 3. And when I simplify that, we get f of 0 is equal to 0 plus 0 plus 3, meaning we get 3. All right, so again, this basically tells us that our y equals 3 when x is 0. So our y-intercept will occur when y is equal to 3, or at the point 0, 3. And that's it. Voila. All right. So that's our y-intercept. Very, very lovely. But now let's look at our x-intercepts. Okay, so these guys occur when y is equal to 0. So I'm going to rewrite the function. So we get f of x equals x squared plus 4x plus 3. And now I'm going to plug in 0 for y. So that just means we're going to replace f of x with 0, and then copy down the right side, we get x squared plus 4x plus 3. All right, so now I'm going to factor this quadratic. Again, my first two terms, they need to multiply to x squared. So I get x times x. And the next two have to multiply to 3. This one was really nice to us. We just do 1 and 3 because that multiplies to 3. And again, we can check it really quick. Multiply, multiply. So we get 3x plus x equals 4x, which is exactly what we have there, meaning we factored correctly. Awesome. Okay, so once we factor, now we can use ZPP, set each factor equal to 0. So I get x plus 1 equals 0 on the left, and I get x plus 3 equals 0 on the right. Okay, so these ones are really nice. On the left, I'm just going to subtract 1 from each side, so that will give me x equals -1. On the right side, we can subtract 3 from each side, so we get x equals -3. And what does this all mean? Well, we got two x-intercepts. They occur at x equals -1 and x equals -3, meaning that they have the coordinates of -1, 0, and -3, 0. Okay. So again, whenever you look at x and y intercepts, you can either express it as a value, or as the coordinate points. All right, now let's look at number 3. So for number 3, what I want you to do, I want you to try this one on your own for a bit. So go ahead and pause the video right here. And I want you to, go ahead and copy the problem down. Try solving this one on your own. And then once you are done solving, go ahead and play this video to see if your solution matches with mine. All right? Sorry, I'm also just being a little bit OCD with my little, what's it called? My pens. Okay, there we go. So when we solve for the intercepts here, similar idea. Okay, so we get y-intercept. We're going to plug in x is 0. So I get g of x equals x squared plus 7x minus 18. And when I plug in 0, I get 0 squared plus 7 times 0 minus 18, which means I get 0 plus 0 minus 18. Ooh, so this tells me that our y-intercept occurs at negative 18, or when y is equal to negative 18, giving us the coordinates 0, comma, negative 18. Okay? All right, now let's check our x-intercepts. So again, I'm going to use y equals 0 to solve. All right, so rewriting the function, we get g of x equals x squared plus 7x minus 18. So ugly, sorry. Okay. All right, so now when y equals 0, we just set our function equal to 0. So we get 0 equals x squared plus 7x minus 18. All right, next step, we want to factor. So I'm going to factor this quadratic here. Again, the first terms, they multiply to x squared, which means x times x is x squared. The next two terms, we want to be careful here. They need to multiply to 18, but somehow combine it so that when we check our work, it will give us 7x, positive 7x to be exact. So I'm thinking of numbers. I'm leaning towards 9 and 2 because 9 times 2 will give me 18. But which one will be negative? How about this? Negative 2, positive 9. Let's check that. Am I right? So I'm going to multiply these two pairs. So I'm multiplying x times 9 is 9x. Negative 2 times x is negative 2x. Ooh. So 9x minus 2x gives us 7x. Haha. It matches. Awesome. So that means I factored correctly. I'm going to go ahead and erase that scratch work. And now I can set each factor equal to 0. So we get x minus 2 equals 0 on the left, and x plus 9 equals 0 on the right. Okay, so on the left side, to solve for x, I'm going to add 2 to both sides, which means x equals positive 2. And on the right side, I'm going to subtract 9 from both sides, which tells me x equals -9. Ho, ho, ho. Oh, nice. So when we get that, this tells us that we have two x-intercepts. One is at x is 2, the other is at x is -9. And if we are to express this with coordinate points, we get a solution, aka an intercept or a 0 or a root at 2, 0 and -9, 0. And that's it. Okay. So again, just be very careful here. I know it's easy to get lost with some of the math, but be careful because when we express, especially with coordinate points, you just want to be careful here. Excuse me. But it's also quite intuitive, right? For our y-intercepts, again, we know our x will be 0, which can be expressed here, and we know our y will equal -18, so that gives us the coordinate of the y-intercept. For our x-intercepts, we want to be careful here because we know the y is 0, but then our x's, or the x values, is what we obtain. So that's how it will be expressed for our coordinate points. Okay. But that is solving for x and y intercepts with quadratic functions.